We are going to see the continuation of the last chapter. Okay, we have seen their fundamental and derived quantities. Now the basic building blocks, and from that what we have derived. Say okay, so basic building blocks and then the derivation from there we have seen there. Now we are going into the larger units measurement. Okay, so larger unit measurements. What are the larger units we can see? Okay, if you know about the distance of the earth and the sun. Okay, how will we measure the distance of the earth and the sun? Is measured in an astronomical unit, right? So this is indicated by astronomical unit indicated by AU, right? So distance from center of the sun to center of the earth. So if you have a diagram, 1 minute. Okay, so I will draw here distance from the center of the sun to the center of the earth. This center we will mark it. Okay, so center point to center point, this distance is 1 AU. Center of the sun, center of the earth. Okay, this distance is okay. So sun, if I want, I make in mention. Okay, this is sun and that is earth. So distance from these two centers is the astronomical unit. So next larger unit we are going to see, we have heard so many times, it is light year, right? What is light year? If we remember, it is defined as the distance traveled by the light. Okay, the distance traveled by the light, it is from there, traveled by the light in 1 year. It is given in the name itself, so you can easily understand. In 1 year in vacuum, that is the word you have to mention. In vacuum is called 1 light year. So it is about 9.46 into 10 power 15 meters. 1 Ly is 9.46 okay into 10 power 15 Ly. Okay, next larger unit we are going to see. We have measured these things in space. One is the distance between sun and center of the sun and center of the earth, that is astronomical unit. Second one, light year, we have seen. Third larger unit is, I think this is not quite common, we heard, this is parsec. Okay, defined by the letter small p small c. Okay, parsec. What is mean by parsec? Distance measure used to measure the astronomical object outside the solar system. Okay, if you want to measure something outside the solar system, we are using this unit. Okay, so this is the distance used to measure the astronomical, we will write this way, astronomical objects outside the solar system. Outside the solar system. This is the 1 parsec. Okay, so what is 1 parsec is equal to, okay, this is equal to, this is 1 parsec equal to 3.26 light year. Okay, this is the answer you have to remember. Formula for parsec. Okay, these are the 3 things you have to remember. One is this AU, second one Ly, and third one PC. So 1 AU equal to 1.496 into 10 power 11 meters. Okay, the third largest unit is Ly, that is light year. 1 light year equal to, we have seen, 9.46 10 power 15 meters. The last one is parsec. Okay, we will indicate by PC. So 1 PC is 3.08 into 10 power 16 meters. Okay, these are some of the larger units we have seen so far. There are also smaller units to be counted. They are as follows. Okay, we will see one by one again. These smaller units, and they are in meters how much. Okay, you will see one by one each. The smallest one is Fermi. Okay, Fermi defined by the letter small f, which is equal to 10 power minus 15 meters. The second one is angstrom. Okay, defined by the letter a power 0 or degrees, whatever it is. Okay, 10 power minus 10 meters. Then little bit more we will go, that is, we know this one, nanometers. Everybody have heard it. So nanometer is nm. So it is 10 power 1 less, it's 10 power 9 meters. Next one is micron, which is otherwise known as, micron is, how will we define, 1 minute, how will we write it? It is mu and meters. Okay, mu and meters. So it is 10 power minus 6 meters. The next one is millimeters. This we heard so far. Okay, this we have read in from the very small age, that is 10 power minus 3 meters it is. Next one is centimeters. Okay, this is defined by the letter cm and it is 10 power minus 2 meters. So these are some of the smaller units. These two units, that is Fermi and angstrom, are still in use. These measurements are still in use. Okay, that's what I have meant there with the symbol. Okay, can we go to the next thing? Okay, next one is some units and their definitions. We have seen in their fundamental basic part what is what. Now we are going to see one by one and their units also for their conversion. Okay, we know what is mass. What is mass? How will we define mass? It's the amount of matter, right? Mass is the amount of matter contained in a sub-object. Okay, it's the amount of matter in an object. This is the definition. So what are all the units we will use? So 1000 grams 1 minute. Okay, I'll write okay, 1000 grams. Okay, 1000 grams equal to 1 kg, right? Then 100 kg, okay, equal to 1 quintal. Next larger one, 1000 kg, okay, equal to 1 ton. One thing, one more in between. So 10 quintal equal to 1 metric ton. Okay, these are all some of the units you should remember while calculating the answers. Okay, next one is atomic mass. Okay, next one is atomic mass. We use this mainly in the chemistry part, right, for the measurement of to find the mass of protons, okay, neutrons and electrons, where this is the part it is used. So it can be defined by the letter small a, small m, small u. No space in between, so don't leave the spaces. Okay, it is a, m, u. This is the symbol of notation. So 1 AMU, that is one atomic mass unit equal to, it is it is 12th. Okay, it is 1 by 12th of mass of C12 atom, that is C12 is carbon atom. That's all. It is 1 by 12th of the mass of carbon atom. Next part is daily usage. Next one we will go with time. Okay, time is the duration of an event or interval between the events. Okay, interval between events. Okay, so what are all there? It can be measured in days, Okay, larger units I am saying month, year, okay, and the one millennium, MI. This is millennium. Okay, oh, I made a mistake. This is E. 1 minute. MI, LLI, okay, LLE, NNIUM. This is millennium. So these are the larger units. Okay, here use the smaller part we will use is seconds. Okay, 1 millennium is only for one thing. I will write 1 millennium is how much? 3 into 10 power 9 seconds. Okay, that's the unit for time. Last one is temperature. Okay, for temperature is the for where will we use it to measure the hotness or coldness, okay, of an object, of a body, whatever it is. Okay, we will use it. So it is measured in Kelvin. Okay, it is measured in Kelvin. It is defined by the letter K, or degree Celsius. Okay, this is degree Celsius. We will use, or degree Fahrenheit. Okay, these are the things we will use it. So if you want a formula, this is 0 degree Celsius plus 273.15. This is for Kelvin conversion. So it is 273.15 Kelvin. No degree should be there for the Kelvin. Okay, this is the formula to be used for converting. Okay, or if you want to convert to from Fahrenheit to Kelvin, from Fahrenheit this is formula 1, this is formula 2, this is from degree Celsius to Kelvin, and this is for 0 degree Fahrenheit minus 32 into 5 by 9, okay, plus 273.15 is 255.372 Kelvin. This is one another formula. Okay, this is one formula 1, this is formula 2. Okay, these are some of the units we are using in daily to daily calculations of mass, temperature, atomic mass unit, and the time taken. Okay.